We should be live. Hello, hello. Testing. If anyone's already here or you're joining and you can hear me, let me know in the chat. Say hello. It's always fun to see who is watching and maybe where you're watching from. That's another little fun tidbit to learn about. Also, if you want to share more about why you're interested in learning about LLMs or LLM pipelines, let me know. Like if you're working on something, building something, put it in the chat. And we'll get started here shortly. I think I'm live 2 minutes early, so we're going to wait a few minutes for people to join in. So again, it's definitely more fun, probably for everyone, if you say hello in the chat. I'm going to say hello in there myself. And I am streaming from Seattle, Washington in the US. And I know we get people from all over the world usually. So it's really fun to see where people are tuning in. And sometimes you're up really, really late at the workshop, which is fun to see as well. Go ahead and share my screen. Again, we'll get going here in a few minutes. And I'll probably mention this a couple times before we get going as more people roll in. But today we're going to go through a workshop. There's going to be some slides just to kind of set up a little bit of what we're going to be doing and make sure everyone's on the same page. But we're going to go ahead and build a pipeline, like a ML pipeline, AI pipeline for fine-tuning a large language model. And it's going to be a BERT model today. That's partially because we can fine-tune it pretty quickly. And if you haven't used a BERT model before, it's an encoder-based model. We'll talk a little bit about it later. But it's actually one of the LLMs that kind of really brought LLMs to the forefront and made people talk about them more because it had really good results. It was from Google. It's a transformer-based model. And it's really good if you want to fine-tune a lighter weight large language model to be able to do things like classification or entity recognition on unstructured data, so text in this case. And then we're going to actually build an app with that model after we fine tune it, and we'll actually be able to serve it on a little Streamlit app, and you'll be able to interact with it. So we're going to build a sentiment analyzer today, but it's a more complex one than if you've ever used just like an LTK model. This is a transformer based one, and then also this pipeline can extend to more complex models and workflow. So again, today we'll be able to go through this in about an hour, but you could take what you learn and bring in much more complex models. And I'll probably do workshops on other types of models too. So let me know what you're interested in learning about. Obviously, like doing this with DeepSeek or some other chat-based model would be cool. And you could take what you learned today and change a few lines of code and be able to fine tune those other types of models in here, because we will be using Hugging Face as well. And most of those models are also hosted on Hugging Face. So again, you just change a few lines of code from what we have here, and you should be able to do that with those chat-based models. So actually, again, while people are tuning in, I know it's just 12:01 right now. There'll probably be a little bit, a couple more minutes while people are arriving. I'll just kind of reiterate again what we're going to go through. But while you're waiting, if you want to follow along, which hopefully you do, it's probably way more fun if you follow along. There's a couple links for you. One is you can sign up for the AI platform we're going to use today. It's free. There's no card required or anything like that. You get $30 of free cloud credit. We're only going to use a tiny fraction of that today anyway, but it's super easy to do. You just need to authenticate with your GitHub account. If you do have issues, let me know in the chat. Share your GitHub handle, and I should be able to push you through. Sometimes if your GitHub doesn't have a lot of activity or isn't very old, it might flag you as a potential spam. And then also, I'm going to share the code right now, so we will walk through this code later. And I just saw a chunk of people come in, so I'll reiterate this again before we get going. But I'm sharing links in the chat for if you want to follow along. They are also in the description of the video. So if you lose them or you're watching the recording of this later, you can come back and find them in the description. So the main thing is just that sign up. Again, that should be pretty quick. And then this is the code we're going to go through. You want to hit this probably open in Colab link. It's going to be the easiest way for you to run this. You could install the requirements local if you want, but I'm going to be doing it in Colab to make this as seamless as possible for people to follow along. And here is the direct Colab link as well. And I'm going to share these one more time in the LinkedIn chat because I think I'm posting them in YouTube, but not on LinkedIn yet. They're in the, if you are watching on LinkedIn, they're in the post as well. All right, so I see people coming in. Again, feel free to say hello in chat. Makes it way more fun for me, but probably more fun for you as well. And then also, if you have questions outside of this workshop, you can ask them in the Slack channel later. So again, if you're watching the recording or just you go through this later and you're trying to put in a different model, that Slack channel is going to be a good place to ask questions. But I probably won't see them during the workshop. So ask questions in the chat during the workshop, and I will try to monitor them and answer them as we go. I might accidentally miss them or something like that. So feel free to ask them again. And also make sure we have time at the end if I didn't get to any as well. And with that, I think, again, more people will probably join in, but I'm going to go through slides and then we'll go do hands-on code. And then so feel free to ask questions as we go. Cool. Saw another chunk of people come in. I feel like it's usually around like 5 minutes after start time that we reach kind of that peak. So welcome everyone. Again, say hello in chat. No one's said hello yet. So I see quite a few people here watching, but the chat is quiet. So one of you should fix that. Oh, and then so while people are still joining in here, we're going to build this pipeline. Like you kind of saw a visual of it. We'll have this whole platform. We're going to use a Python SDK. And this is going to give us a task. Each one of these is a task in our pipeline. And then the pipeline, the workflow is kind of tying all those things together. We're going to download a data set. We're going to download a transformer model. We're going to fine tune that transformer model with our data set that we downloaded. We're also going to visualize that data set. So I always really like visualizing my data as I'm training or before I'm training on it. You can embed any visualizations that could become HTML right in your task here. So it's really cool. This just has an example of each negative, positive review that we're going to train on. But you can do charts and interactive charts even with Plotly in here, which is really cool. So I love having this as a version in my workflow. Every workflow that we run is version. So you actually have kind of these artifacts tracked over time too. So like what was the exact distribution of my data? You can always come back and look. We're going to evaluate the model. And then we'll run one kind of batch prediction with some extra text to see how it performs. And then we'll actually take this model that we train and build a little Streamlit app with it. So then we could take some other data. So today we're going to fine tune this model to classify movie reviews as positive or negative. Again, you could extend this to more complex use cases and models for everything that you're going to see today. And we'll have this little Streamlit app. And then it's going to return, was it negative or positive for us down here, which is pretty cool. We'll also look at how to serve models with batch serving as well. So we'll see a couple of different ways to kind of serve this model once you fine tuned it. And with that, cool. I think a lot of people are here. So let's get going. Again, reiterating one more time. If you want to follow along, which is probably going to be more fun, sign up there. Free, no card required. Just authenticate with your GitHub account. Again, if you have issues, let me know in the chat and share your GitHub handle, and I can hopefully push you through. And then that's the link to the code. Hit that open and collab button if you want to poke around before I get to it, but I will walk through all the code as well. All right, is everyone ready? I see people are saying hello in chat now. Awesome, thank you so much. It makes me feel a lot less lonely when I'm presenting this virtually, so this is great. All right, so I kind of talked about what we're going to do. I showed an example of it. Again, we're going to go through some slides and then go into the hands-on code part. So little tiny bit about me. My name is Sage Elliott. I work at a company called Union.ai. We are a AI workflow and inference platform. And we're going to see some of this in action because it's going to be what we use to build our AI pipeline today. But also, if you end up using other tools in the future, I hope just the concepts that you're going to learn as we do this will stick with you, because I'm just going to talk also about some best practices that you can implement. I live in Seattle, so that's where I'm streaming from. Some people too know me from an AI book club I run. That's really fun. We read a new book every month. If you're interested in learning more about that, just connect with me on LinkedIn. You can also find it on a lot of the other meetups that I cross post like these types of events in. It's the most I've ever read, which is in technical, like most I've ever read technical book wise in a year, and it's been really fun. And previously, I've worked a lot in computer vision, ML monitoring and evaluation, and then also have a background in hardware IoT. And I guess MLOps should be on the other lines above, where I've worked in MLOps and ML monitoring and building pipelines like you're going to see today. And if you want to connect with me on LinkedIn. I'm pretty active on there, so you can message me there. But also, you can connect on Slack. This is kind of an MLOps Slack that I help run. It's called Flyte, Flyte, and that's actually the open source orchestration platform that Union's built on top of. It started at Lyft, that's why it's spelled that way, and then now it's run by the Linux Foundation, and then Union was started by the engineers that created it as kind of a company around it. So you'll see a little bit more of like what this looks like in action, but that's what that Slack is. It's our open source community Slack. A little bit about you. So I saw people said hello earlier. This is fantastic. But if you want to add a little bit more, even if you already said hello, maybe where you're watching from, what are you working on, and why are you interested in maybe learning about how to build a LM pipeline? And then also, again, you can um, join in the Slack and maybe do a more permanent introduction there. Someone asked about the quality of the screen. Yeah, if someone else wants to chime in and let me know, I can check real quick on my settings. I thought I had the highest quality. So I know also sometimes because you're live streaming on YouTube, potentially you might have a lower quality setting. And if you hit the setting icon on yours, you might be able to add a higher quality setting. Yeah, because I am streaming in 1080p, so I know it's not 4K, but it should be good enough. It might be on your end where if you have it might automatically be choosing a lower resolution on your streaming side. Good point though too for me to point that out. So if you are seeing lower quality, you might want to fix that and hit the quality icon on your stream side and hit a higher quality there. And thank you, Amir said they have no problem. Cool. So a little bit about MLOps and LLMOps and ML pipelines. MLOps is a set of practices, not really the tools, but you're tying how you're tying these tools together. I mean, you typically aim to deploy, monitor, and maintain ML models or AI models in production. And then I like the terms like reliably and efficiently, but you can use different terms there too. And this is kind of a very, very bare minimum pipeline here. Has anyone seen or has anyone built like some sort of pipeline like this? So maybe you've messed around in Jupyter Notebook before and you've trained a model, but has anyone made a pipeline where you're kind of doing a continuous improvement cycle with a model in production? It feels a little bit different. So typically you have a stage where you're collecting data. You might be pre-processing data here as well as a different step. Again, this is just kind of a bare minimum one. You're going to take that data, train a model on it. Then you want to evaluate that model, make sure it's kind of performing as you would expect on some data. You might poke around with new data. You might have a slice of your data set and see how it performs on it. Then you're going to ship that model, and it really depends on where this model's going or what you're trying to do, what that looks like. So it could be a web API endpoint, it could be a whole application, it could be on a phone, it could be on some deployed little piece of hardware. And every time you do that, then you have to think about how to monitor that effectively. Typically, you want to monitor a model once it's in production, because if you put a model out in production, the data coming in production might shift, or it's called data drift, where the data kind of no longer matches the data that was trained on. Maybe it's changed slightly, or maybe it's changed quite a bit, and chances are your model's just not performing as well on that new type of data. So it's a really, really common problem, and you want to have some sort of monitoring there. And then typically you're going to be collecting that production data, and then you're going to maybe take a portion of that production data or all of it, and then kind of start this loop over and over again. So it's called like the data flywheel or ML lifecycle. And basically, you're just constantly shipping models and then collecting data and then improving them and monitoring them over time. This is a pretty common ML workflow. Has anyone made some sort of workflow like this before, or used like an ML monitoring tool? With LLMs specifically, like you might want to monitor how your responses are coming out of an LLM. Like you don't want to have a customer service LLM be really negative or provide fake phone numbers. These are all things I've actually seen before when I've worked in the monitoring space, helping companies set things up. Like once I was setting up or helping someone with kind of a chatbot for an online store, and we had some data as like an angry customer, and the model just said, "Oh, I'm so sorry you're angry. Call this number." And it made up a fake phone number. So we didn't give it a phone number to call. And we only found that because we had pattern recognition to find when it gave phone numbers. And it was a built-in automatic thing in the monitoring tool we were using. And we're like, "Oh, why did it give out a phone number?" And then we looked at it, and then it just made one up. So stuff like that happens all the time. And monitoring in a way it's always important, but with LMs, it really can go all over the place, right? And you want to make sure that you're probably performing in that space that you want it to. So there are a whole bunch of great tools to kind of put all these steps together. You're not building everything from scratch usually. There's great tools for monitoring like Y-logs, Rise, weights and biases. There's a whole bunch of them in the LM space right now, which is really cool. Training, you've probably used like PyTorch, Scikit-learn, something like that before if you've done ML before, etc. And tying all these tools together, though, we really want to make a workflow. So kind of like if you're here at the beginning, we're actually building this workflow or pipeline today with all these different steps. And inside each of those steps, we want to manage the specific resources and tools, and kind of the compute that those tools are going to run on. So the putting together workflows like this, they're kind of the core of building an ML pipeline and making it easier for your team. So some things I like to think of when I'm building out a good pipeline is, one, cost probably is a thing for your company. Optimization, that can mean different things, but that can mean like speed, optimization of sharing resources. That kind of goes with also another thing I like to think about, collaboration. So what does your team look like? Can you easily hand off artifacts between like a data engineering team and an ML engineering team, and then the team that ships the model? But that does just kind of depend on what your team structure is like. Maybe you're the only ML engineer and you still want to have everything kind of aggregated in one place so you can keep track of it. And then also compliance is something that comes up quite a bit too. Depends on the field that you're in. I think in general, it's pretty good to have versions of everything and lineage on your data. But in some fields in particular, like healthcare or finance area, this is even a more stringent thing. And you want to be able to look at like what happened between the data set when we downloaded it. Did we do something with it? And then like what was the version that went into training a model? And yeah, so I like to think about those things. How can I make it as fast and easy and scalable, especially in the deep learning space, for the team that's going to be consuming this pipeline or working with it? So some things to think about is scalability. If you're spinning up a ton of data for like self-driving car use case, for example, you want to be able to have the compute that can handle that. You want to have reproducibility, so you can ensure that your workflows are consistently reproduced. And I think I didn't mention this before, but the platform we're using today is built on top of Kubernetes. So basically, if we are spinning up a whole bunch of compute for a large data set, we can handle that on our cluster. You want to have versioning, like I mentioned. It's good to be able to go back and like every time you run this workflow, like you might run it a whole bunch of times as you're building out and experimenting. You want to go back and see like the version of the data, the code, and the models, everything in there. You probably already version your code if you've been doing software for a bit. Think about this for everything in your whole pipeline. You get a whole snapshot, and it makes it way easier to troubleshoot or see what happened. And then improved efficiency. You want to allow your AI engineers to focus on, really building the cool part and not having to go through and like write config files or something like that to run models. And often when I've brought these like strategies into people or into companies, you'll see them say like they went from, experimentation, like getting their models out for experimentation from like weeks to days, or shipping models from quarters to weeks. And then again, obviously cost efficiency is a big thing for a lot of companies as well. And just to kind of hammer on some of the points that really allow for these things like we talked about. And I'm going to go through very fast because I want to get to the code here. But optimize for local development. So some of MLOps or some like AI workflow platforms make it harder to kind of build and experiment locally before you kick off cloud jobs. And so if you can experiment and find bugs just on your, pretty powerful MacBook already, even if you're not fully training like the giant model or you're using a subset of the data, that can help a lot because just debugging locally is obviously way faster. And kicking off a cloud job, waiting for a container to spin up, and then finding the error in the logs, and then coming back and fixing it. Leveraging caching in the pipeline. So we'll see this in action today, actually, as well. So here's a simple workflow where we're downloading a data set, pre-processing the data, and then training the model. And let's say we want to rerun this workflow a whole bunch of different times and change these hyperparameters for the model to see what works best. And so we don't need to download the data set and process the data each time because this didn't change for us. And we just want to rerun that portion of the workflow so we can enable caching and just pull directly from that each time we run the workflow. Task level resource management and containerization. So this is a really big one where if you ran a pipeline before, potentially you had some sort of monolithic workflow. And so imagine you were building a workflow like we saw before, and training the model requires like a whole bunch of GPUs or several really expensive GPUs. And downloading the data maybe takes a couple hours because it's a really big data set. So instead of running those GPUs for hours and wasting that GPU time, which is expensive, but also you could be hogging resources from the rest of your team, we containerize each step of that task. So we only use the compute we need when the task is running. So in this case, like this has an example of a training model. We'll use a GPU, but for downloading the data, we won't. So for these tasks, if they took a long time, they wouldn't be wasting those resources. This is a huge one where you see a lot of optimization for cost and just resources for your company. We'll also see in the platform that you can see exactly the usage all versus what you allocated as well. So if you allocated too many CPUs here, you could actually bring that down. And again, you wouldn't be paying for that every time you run the workflow. And then migrate errors with type safety. If you ever use some other programming languages outside of Python, you might be familiar with typing. Flight and union, we enforce this in our workflow. So basically, you define the types that are coming into the task and the types coming out. And if you kind of mess that up in your code, it's going to yell at you kind of on compile time. So again, this is just like a way to mitigate errors and reduce the debugging time. And then today, we're going to see all this in action using Union. If you're here at the beginning, I mentioned it briefly. It's a platform. We're going to use a Python SDK with it today. We're going to use the serverless version, which is in beta. So if you do see any errors or anything funky in there, let me know. And it's going to allow us to do the declarative infrastructure for that compute. Versioning, caching, type safety, has a really big, flexible plugin ecosystem, but also a lot of things will just work out of the box in Python, like in the compute clusters. And then it's scalable. So it's built on Kubernetes and has a user interface and a Python SDK, which we'll see in action. And it's built on top of Flight, like I mentioned before. So if you want to check out Flight, the open source project, you can check that out on GitHub. Always appreciate stars as well. And then I mentioned at the beginning how we're going to use a BERT model today. BERT stands for bidirectional encoder representations from transformers. So there's some use cases are like text classification, semantic search, name entity recognitions. It's an encoder-based transformer, and it takes text or other data as inputs and then outputs a dense representation. So if you have read like a transformer paper, you know there's the encoder and decoder part of a transformer. And the decoder part is usually associated with the text generation piece, and the encoder piece is usually associated with basically creating these representations or embeddings. And we're going to be using an encoder model today. But like I mentioned, the workflow and stuff that we're going to see today can extend to more complex models or to those decoder models. So if you're just kind of like what you see today, you can switch a few lines of code probably because we're using Hugging Face and use a decoder model like DeepSeek or something in here as well. All right, so is everyone ready to go and follow along and build our pipeline? So two things, I shared the code in the chat, and again, they're in the description as well, and the sign up link. So if you haven't already, click on both of those if you want to follow along. Again, we'll be building our pipeline and actually then use that model in a little app. And let me make sure I get the right link. I'll go through all the steps the same as you. All right, so then you want to hit this open in Colab button. I'll probably add more text here later. And then this will take you to the notebook in Google Colab. Google Colab is essentially Google's way of hosting a Jupyter notebook that gives us a kind of a free compute space. There's even free GPU time, which we won't be using today in here, but it's a great place to come and experiment with deep learning if you don't have a GPU at home. And this tutorial is going to walk us through building the kind of the end-to-end pipeline for training that large language BERT model that we talked about using Hugging Face. And just by adding, so I'm going to actually show you what some of the code looks like in the Python SDK here before we actually jump in and build that pipeline. So you're going to have Python functions like you kind of normally would, but we do enforce typing. So here I'm saying this function is expecting a data frame to be outputted, and we kind of enforce this. And then on top of that function, you'll see this task decorator. And each of those tasks is one of these nodes in here. And then that task, we can pass in parameters. So in this case, like we were saying, we want caching is equal to true. So it's going to run once and then save the output as cache that we can just keep pulling it from. You can give it a cache version, so you can actually version those caches as well. And then each one of these is a container. So if you're not familiar with Kubernetes, it's essentially a way of orchestrating a containers, which are their own compute environments, and you pass in the requirements that you want for that container. You might have used Docker or something in the past where you compose what these containers look like. We're actually just going to use something built into FlightKit or Union where it's called image spec. And instead of writing Docker files, we can actually write in Python exactly what we want the requirements to be, and then we'll just create a container based on that. So you don't have to mess with Docker files, which is pretty nice too. So we're going to define that, say, this task is going to use this container. And then this is where that part comes in where you can define the exact compute resources you want. So for this downloading data, we just want 2 CPUs, 2 gigabytes of memory. But you can see where this training task, we want 1 GPU and way more memory. So we're not wasting these resources when this task is running. we're only going to use those resources on the train model, which is, again, a big cost saving and resource saving benefit. All right, so actually should have you go down and run this code cell. This is going to install the requirements. Also, actually, what I like to do is save a copy in Drive. You don't have to do this. You can save your own copy. That way you can edit everything, come back and have a save state of this notebook. Like you can make notes in here. You could write your own code, and then it's like yours to keep. So scroll down and then run this code cell. This is going to basically clone the Git repo that we pulled this from. And let me go back. So we can see we have this requirements.txt, and then it's actually going to install that in our Collab notebook here. And this will take probably just like 2 minutes or so as we install these libraries. And while that's happening, it's a great time to sign up for serverless if you haven't already, because that should also just take about 2 minutes. So you can go to get started, and then this will take you to, well, I'm already signed in, so it's rerouting it. That'll take you to a page where you can just authenticate with your GitHub. Again, it's free. There's no card required or anything like that. You just get free $30 of compute credit. And someone said that they're a student at UW. Awesome, right by me. I assume you're talking about the University of Washington, not Wisconsin, but I could be wrong. And you've been tinkering with local setups and workflows, curious to further your understanding and learning of in MLOps and life cycles. Awesome. Well, hopefully this will be a really cool kind of introduction for you to go through. And like, even this might feel like a relatively simple workflow that we're building today, just for the workshop purposes. You really are building a production grade workflow. Like a lot of people use Flight, the open source, and Union in production. Some really large companies like some of the public ones, like, well, LinkedIn switch all their large language model workflows over to using Flight, which is really cool. And then also, if you go look at Union's site, you'll see a whole bunch of logos there. One I know that is really cool is Woven by Toyota. That's their self-driving car division too. There's actually quite a few self-driving car companies that use Union or Flight, the open source. Flight Flight and Union scale really good. So a lot of times people might be on their homegrown orchestration framework or some other orchestration framework, and then when they're scaling up to these massive workflows or workloads like you would have in self-driving, they often end up on Flight or Union. And this should be almost done. Trying to think if there's any. Okay, cool. It's done for me. It's probably done for you pretty soon if you hit that run. So again, Colab gives us a whole little compute environment. And then if you've never used a Jupyter notebook before, has these code cells. But we also have these text cells that we can like write in. So these are text cells here. Once you've made your Union account, you should be able to authenticate this notebook with it. So basically you need to authenticate any environment they're going to kick off pipelines from. And we're going to use that by saying Union create login, serverless in this case. But if you have a bring your own compute, like most companies that actually use us in production right now are on like their enterprise account that has more features, but we're going to be using serverless today. And then we're going to authenticate this device flow. So just run this. And then we'll get a link. It's asking us to click this link to authenticate. And click this. Don't change the lettering at all. And then boom. This should be now authenticated. All right, now, and also I'm going to wait for one person to let me know that that worked for them, at least. If someone, hopefully someone's following along. I do see people in the chat now, which is awesome. Were you able to authenticate in the notebook? Let me know. And someone said, yep, University of Washington. And then also someone said how we know how much CPU and memory we need. They're new to large language models. Depends on the data you have and large language models that you're using. And you might get an idea of like how much memory you need to load that data in. One thing that's really cool is here we have this train model test that we're going to run here in a little bit. Someone said it's still installing requirements, so I'm going to wait a little bit for other people to catch up. One cool thing is we have this train thing. Well, you don't have it yet, but I do, and you will have this in a minute. and we can see each of these tasks. We can click on it, and we can actually see this view utilization button. So for this task, I thought I needed like 12 gigabytes of memory, 4 CPUs, and 1 GPU. And I actually really just need the GPU because everything is running on the GPU in this case. So I could actually tone down, like I really only need 1 gigabyte of memory here, and I really only need 1 CPU, because it's not actually using the CPUs besides just to run the initial GPU or pass the initial stuff to the GPU. So I can actually now have like visualization into the resources that I'm actually using. So like I think it just takes a little bit to kind of have a feel for what you need, and then stuff's going to yell at you when you don't have enough of it. But it is pretty common to be like, I over allocate stuff, or for a lot of people, you over allocate, and then you want visualization into what you're actually using, and then you can bring down those resources. And we actually have a feature too in the bring your own compute enterprise version that has a like, this isn't serverless in all the versions, but there's a bigger kind of cost allocation dashboard that people are finding really useful too. All right, someone said they've authenticated. Several people said authenticated. Um, I think the person said thanks for kind of answering their question. Yeah, and you can look up like a lot of stuff's documented, like how much GPU memory you might need for a model. There's also really cool libraries like from Hugging Face. There's one called Accelerate, where if you don't have enough GPU or GPU memory to load in full models, it can actually offload portions of it to CPU or to hard drive. So I would check that out too. There's just a lot of really cool stuff right now around like optimizing all the different resources you have and how can you run large models on computers without a ton of resources. Okay, so we're going to go ahead and build that whole pipeline that we saw. And again, if you were here at the beginning, I went through a preview it already. I'm going to do that again. But what I want you to do is go ahead and just run this line, and then I'm going to talk about what's going on here. But if you run this for the first time in particular, for everyone following along right now, it's going to take, I don't know, maybe 10 plus minutes to run the whole thing. And part of that's because it has to download all those libraries like we did in Colab Notebook, but it has to do that in Union. So it has its own container that it can then pull to run in our pipeline. So for you, it's going to take a little bit longer to run the first time. And for me, it's going to be shorter because I've already run it. So I'm going to go through all the code here, but I'm going to open this up first once it goes. So for you, it'll probably say like no build found, and it's going to start building a container with those requirements that we kind of saw before. For me, it says skipping build because it already exists for me. And then now it's going to be running this workflow. So I'm going to click on that URL. And then there's different views. Here's all the nodes. I kind of like this graph view. So we can actually see that for this download data set and model task, they have this little icon here. If I hover over it, it says this execution was read from cache because I have caching enabled. And again, we'll see this in action in the Python SDK in a second here. But yeah, so for me, it's also going to be a little faster because I don't have to download the data set or download the model again because these are cached. And then I'm just pulling those in to my train model node or task, and then my visualize data task. And then once this is done, the evaluate model and batch prediction task are going to kick off. And then we'll come back to this, but I'm going to go through all the code of what's going on here. There's a lot of cool stuff in UI you can do too, like relaunching specific tasks, relaunching whole workflows. And we'll see this workflow is parameterized, so I can actually rerun this whole workflow and just pass in different hyperparameters. So again, we'll see this in action. Somebody asked, so the container image Python code generates a Docker image. Does it write a Docker file for the image? So we'll see this in action here as I open up the code. So one, you can go look at the GitHub. I think if you click on these links, it'll take you to the GitHub code. What I'm going to do, try for this workshop, is navigate the code kind of in here. So there's this folder icon. We can see here's this BERT LM classification pipeline. That's the GitHub repo we downloaded. And if I click on any of these like .py files, it's going to open up in an editor here, and I can like kind of drag it over here. I'm going to see if this works good for the workshop because again, Colab just makes it really easy for everyone to follow along. But I do have this locally too, so if it seems too confusing, let me know and I can go back to my VS Code. But I do want you to be able to click around and follow along as well. So we're running this workflow, and we can see that it lives in this workflow folder, and it's called train pipeline.py. And then inside that file, the actual workflow is called train pipeline. So I'm going to open up this workflow folder. Come on, Colab. If it gets stuck, you can always hit this little refresh button here. And then I have this train pipeline.py folder. So I'm going to click on that. And can everyone see this okay in the stream? Think it looks probably good, probably big enough for people to see, but let me know if you can't. And now I'm going to walk through what's going on in this pipeline. So, or sorry, in this workflow. And then this workflow is pulling from tasks. So you can break up this project however you want. I like having different files for tasks, especially if you have more complex pipelines. And again, you could break up however you want, but I have one for like data, one for my model functions, and then one for inference. And we'll look at these all in a little bit. But first, let's just look at the workflow. So the workflow is a collection of tasks. So when we go and see all these nodes, this is the order they run in, and we can see that like it downloads a data set, and then that data set, part of it at least gets passed to the train model, and part of it gets passed to this visualized data. And we define that workflow and that collection of tasks or in this workflow decorator. So we saw the task decorator before, defining the compute and stuff we wanted. Then we define how that runs kind of in this workflow function. So we just create a Python function. In this case, it's taking in a string. So we can actually switch out different BERT models here. Again, this is parameterized. So every time we run the workflow, we could just adjust these either when we run it from the terminal or from the SDK in other ways, or from the UI. So we could put in a different BERT model if we wanted, but this is the one it's going to pull by default. By default, it's just going to train 3 epochs. So it's going to look at our whole data set 3 times that we pass into it. So again, this is kind of for demo purposes in the workshop, but you could make the epochs way more than just 3. Like it probably needs to look at this way many more times to probably get really good at knowing patterns in that data set. And then we're going to pass in some extra test data. So I like to sometimes in my pipeline just have another prediction task later after it's already trained and after the evaluation step. So I can pass in data that I know probably maybe isn't in the eval. Maybe this is stuff that's like really out of range, or just something I know like it's going to have a hard time with, or I just want to kind of verify something. So this is also just going to allow us to pass in some other data. But again, we'll see this in action and how to actually just have this app deployed with new data shortly. So first we are calling our download data set. Again, we'll see these are tasks. We'll go in the task files here shortly. And then we're calling download model. And then we're passing in the data sets to that visualized data task. And then for a train model, this is, for train model, this is taking in the download directory for the model that we had before, training data set, validation data set, and then the number epochs that we want to train for. Then we have our evaluate model task, and this is taking in the train model, not the downloaded model. So once it's trained, we're going to have a new directory where it passes a train model out, the one that we fine tune, and it's going to take in the test data set here. And then we have our batch prediction task. So these are all a collection of tasks, and I can see they're imported from this task folder. And then there's some that come from data, there's some that come from model, and there's one that comes from inference. So I can click on this data.py. And I'm just going to go through kind of maybe high level here. Let me know if you have any questions, so I can always come back to these. Some of it's going to be repetitive too for like seeing how the different tasks behave. And I'll just talk about the imports kind of as we use them. So one, we'll talk more about this later, but we can define artifacts. And so artifacts are artifacts are a way for us to define something that we want to track and then be able to like store and query them and pull them into different workflows really easily. So this goes really good with the collaboration step. Someone made a great point in the chat. I totally forgot to mention, or I might have mentioned it at the beginning, but I didn't make it very clear. So the data set that we're using today is the IMDb data set. We'll actually see this in the download data set function right down here. But basically out of this, we're going to create 3 artifacts that we actually want to use is train data set, validation data set, and test data set from the whole data set that we download. And I'll just scroll down and we can see what the IMDb data set looks like here. And then here's our first task. We're passing in a container image, and I get this from the containers.py file. And someone was asking about this earlier. So like I had mentioned, there's a built-in thing in Flight and Union called image spec, where you can actually pass in way more requirements than just like the packages we want. In this case, we're just passing in our requirements.txt. But you can pass in like CUDA versions, you can do apt-get, you can do all sorts of different things that you would want in your container. And then this is going to go make that container file for you, like the Docker image. So you don't actually have to mess with Docker images at all. And it's really cool. I like it way better than making Docker images, just declaring everything in Python. And then also just lives in your workflow basically here. So you can actually go back and see like what was happening, what that container looks like. So back in data.py, I'm also enabling caching. So it's going to download it once. And then as long as this cache version doesn't change, it's just going to keep that stored. And we're only going to use 2 CPUs and 2 gigabytes of memory for this task. And then it's going to here's our function, download dataset. We're going to output, because we have to remember strongly type what's coming in and what's going out of functions. This annotated thing is actually a thing in Python where you can have a file type and then some metadata attached to it. And this is how we declare artifacts in Union, and then we're able to store them. And again, we'll see this in action where this allows us to add like lineage to data going across our pipeline. And also we can just query versions of that data and easily pass them to other pipelines and workflows. So like we can train a model, now it's hosted somewhere, and then we can go specifically like query the latest version of that model and then serve it, which is what we're going to do today. And flight file and flight directory are specific things in flight. Again, that's the open source orchestration library or platform underneath Union. So you might see like flight kind of in here a lot. Flight file and flight directories allow us to basically make persistent data that live outside of containers. So if you haven't worked with containers before or Kubernetes, basically every time you run this, it spins up compute. So it spun up compute to train our model for like 7 minutes here. And then it spun that container down. So we don't need that GPU anymore. It gets rid of it. So when you spin down a container, though, the data that was in that container no longer exists by default. So you want to be able to pass that data out. And that's what flight file and flight directory does. You would say, in this case, we are passing out a flight file of our data set. So now we have a directory where it's going to live on some sort of blob storage. And you don't have to worry about it with serverless. But if you're using like bring your own compute, that could be like, AWS S3 or S3 by Amazon, or like Azure Blob Storage, or I forget what GCPs is called. You set that up when you're like doing the bring your own compute. So it's a way for us to persist data outside of containers. And then we're loading in our IMDb data set. And then we're getting train data from the train section, test data from, there's a test section in there, converting those to pandas data frames. We're also going to create one other section of our data called validation. So it's pretty typical in deep learning. You have 3 data sets. You want to have train, validation, and then test. You have train for your model to learn from. Validation is, while you're tuning your model, you want to look at like loss and accuracy or whatever metric is that you're interested in. And kind of as it's learning, and you might say, ooh, I need to adjust my hyperparameters or something like that to make it learn better on this data. So use validation to kind of see what's going on there. So train data, the model actually looks at validations for you to kind of see how the model's performing as you train it. And then you have another holdout one called test, which you don't use to adjust hyperparameters. And then once you kind of feel confident your model might be okay, then you would use that in the evaluation step. And then so we are just making a directory, saving our CSV files here. And then actually, I don't know if we really needed to save them here. We could have just probably made them a data frame and passed that out. But we saved them. And then we are basically just passing out the path of where they live, that flight file persistent path, as an artifact. And then again, like I said, we'll see this later, but we'll be able to query this and see lineage across our data. And then we have this visualize function. Again, I'm going to go pretty fast in here. It's a lot of what we saw before. We are just enabling or passing a container. One new thing is this deck is equal to true. And so if I go back to my pipeline and I click on visualize data, we have this button now called deck that contains several tabs up here, but this is a tab that we specifically create in the rest of that function. And in a deck, you can embed any HTML that you want. So someone is asking about, what does this data set look like? This is an example of, now we have the train, validation, and test split. And in here we can see the distribution. So there's 20,000 samples in our training data set. And there's 2 labels, label 1, label 2, or label 0. And that means that there's it's positive and negative, basically, is what we're doing here. And here's one sample of a positive review. And then here's one example of a negative review. And then this is kind of overkill because this is a really clean data set from Hugging Face, but I also like to see maybe the distribution of labels and stuff like that. So you can create charts and embed those directly in here as well. And again, you can use interactive charts like Plotly if you wanted as well. And then we do the same thing for validation and our test data set as well. And basically, the rest of the function is doing that. So like, I probably won't go too deep in here. We're just getting the first negative and positive review of each data set. We have a function that uses plotly to make those plots we saw. And then we convert them to base64, which allows us to embed them directly in HTML. And then this is just a little HTML thing that you can do in Python. And that's what gives us the report. And then we append the HTML to the deck, and then we insert it at position 0. So that's in our data.py. And then if we went back to our train pipeline, after that, we have stuff going on with our model. So I'm going to open up model.py. And then we have just one artifact here we define that is our fine-tune IMDb model. So we're going to fine-tune the model, save it as an artifact. So again, we can query it easily across like teams and workflows. Very similar to what we saw for tasks for just downloading a model. We give it a cache version. We just need a couple of CPUs and a couple of gigabytes of memory here. And then we're going to download a model, save it as a flight directory. This is a complex model from Hugging Face. So instead of just like one small model file, it's a whole directory of things. So I'm saving it as a directory versus a file. And again, flight directory or flight file are ways to persist that data outside of containers. And then we're assigning our model is auto model for sequence classification from pre-trained. And we're going to pass in the model name. So again, this is a parameter that we saw in our workflow, but we could change this when we run our workflow to a different like BERT model, and then it'll automatically, that's what the auto part here is for, kind of download the correct model in this case. And device map is just going to use a CPU here. And then we're going to also create a tokenizer from that. And then we're going to save the model and save the tokenizer. And the model is like the BERT model for it. And the tokenizer, if you're not as familiar with LLMs, is kind of the way that that specific model chunks up or knows how to read text in this case. Tokenizing can be slightly different than like per word. So every kind of model has a way of how they chunk up text to read. And you typically want to use the same tokenizer from that model. Otherwise, it might not perform as well. And then we have our train model step. So very similar, but one big thing is that we are declaring we want a GPU in this case. So we're adding a little bit more resources here. So we're only going to use a GPU when training though, which is great. And then we're going to pass in that model directory that we downloaded, again, which is cached. And then the train data set, the validation data set. And then by default, the amount of epochs, the amount of times it's going to look at the whole data set is 3, but we can pass in a different number to this. Again, just for the workshop purpose, it's going to be 3, and we'll get decent results. But to get really good results, you would probably want to have this number be a lot higher. We're going to make sure that the model gets downloaded in here. So when you have something like a flight directory and you're using it in another workflow, or another task, you can call .download on it and ensures that it's in that task then. And then we read in the model directory from using what we did before, but now we're reading in our saved model. So the auto for sequence classification from Hugging Face and auto tokenizer. And then we're loading in the data sets. And one thing to note here too, again, just for the workshop, we're going to be looking at the first 500 samples, or actually it's kind of a shuffled random state, but we're going to be looking at 500 samples, not 20,000, because 20,000 will take a lot longer to train on. And then we're going to be evaluating on just 100. So you could get rid of these numbers, get rid of the sample part, or just up this number. Again, for the workshop, we want to be able to complete this in just a few minutes. Then we're going to convert the data frames to Hugging Face data sets. So we read in those data frames, and then this goes into like a PyTorch data set that Hugging Face can use. We get our tokenizer function, and then we create some training args. We don't pass too much in here, just the number of epochs, and we want to evaluate on every epoch. And then Hugging Face has this built-in method called trainer, which makes it really easy. By default, this is going to train all the weights in the model, but you could freeze different weights if you wanted to as well. We're going to pass in that model that we downloaded, going to pass in the training args, going to pass in the tokenized train data set and the tokenized validation data set, and then we call .train on it. And later on for the evaluate step, we'll call a .evaluate on it, and it's going to read the evaluation data set or the test data set, run through it, and then give us the results. And we're going to save this model to this output directory, and then we're going to return that now as an artifact. So again, we have this fine-tune model that we can then query and pass to other workflows or use in production. So we have an evaluate step. It's kind of similar to above, except for we're just reading the test data set. And then we have a function for computing metrics. It's going to give us accuracy, F1 score, precision, recall, just because we're doing a classification task today. Training arg, similar like before. But instead of calling .train on this, we're calling .evaluate. And then again, like I mentioned, that allows us to pass in all the data and then get evaluation results on it. So that was all our training. We had one other thing we called in our pipeline, which was predict batch sentiment. And so we are downloading that model that we trained, initialize the tokenizer just like before, and then we're initializing this pipeline thing from Hugging Face that makes it really easy for us to say, like, this is a text classification pipeline. Here's the model, here's a tokenizer, and then we can pass in some text and say what batch size, like how much text we want to be able to read in. And then we'll get predictions on this. So if we go back to our pipeline, and I know this was a lot to go through pretty quickly. So again, I'll be sticking around afterwards if people have other questions, want to go deeper in any of this stuff too. But also you have all the code. I know for me, like I love jumping in, running stuff, and then maybe working backwards a little bit and see what was happening there. But you can probably see how we put all this stuff together. You saw how we enabled caching. Again, the first time you ran it, it wasn't cached, but if you rerun this whole workflow, which by the way, you can do from this relaunch button directly in the UI. And you can see there's parameters. So you could pass in a different BERT model from Hugging Face. So you could just pass in, I think, BERT cased or BERT based case would be a different one. You can change the number of epochs here. And then this is the prediction data that we pass in for the last step. And we have a couple other ones we're going to pull up. So we looked at visualization of our data. Train model. What I should do, I didn't do this, is create a deck here and then actually log like our loss in accuracy per step. I think I'll add that in next time. We have our evaluate model, and we do have a deck here. I didn't make this pretty though, but by default, you can see the output here as well. We can see that this was our loss, and then we can see that our model accuracy in this case, let's say that's what we're going to be judging our model on, is 88% just in 3 epochs looking at the data, which is pretty good. You can also see inputs that went into that task, outputs. Actually, this is kind of a better format because I didn't make a good format in the deck. So we see eval accuracy was 88% here, and then the other scores as well. And you can get some other information about the tasks. And then let's look at our batch prediction task here. If I look at the inputs, these were the 2 kind of texts that we passed in. And if I look at outputs here, we can see one was labeled label 1. I think that's positive. Yeah, positive. And it's like 88% sure that's true. And the label 2 was negative, and it's like 74%, confident that that's true label that for it as well. Now, let's go ahead and if we wanted to, we could actually rerun just this task 2. And you could pass in, so this is a list. So you could pass in different text here and see how it classifies it, which I definitely recommend you doing. And then you would just hit launch. Actually, I'll do it right now just to show that you would hit launch if you change that text, and then it'll take a little bit to initialize this task. Once it does it, then it'll perform the prediction. Then we click in that task just like we did before. So once it's done, you'd see the output here. And just noting, all the stuff that we're seeing in the UI here, you can also do through the Python SDK. So if you want to like navigate all the previous executions, like these are all the ones I've run before, grab one and look at specific output or anything like that, you can do that in the Python SDK. We have one other big thing to kind of show before, like we have that model trained now, right? Now, how do we use that model? And the cool thing is, again, we made it an artifact. So if I click on this artifact tab, we can see that our workflow actually created several things. We have a fine-tuned IMDb model, and then we have some other validation data sets as well. If I click on this fine-tuned model, we can see that it came from this task, this train model. And then if we used it somewhere else, like in another workflow, like actually we'll use it in a workflow in a little bit, you'll see it gets extended. So it's a really cool way of seeing the lineage between artifacts, in this case, a model, but you'd also see this with data sets. So if you're using data, download a data set, pre-process data, do something else with that data, you get a whole kind of step-by-step thing of what happened. And you can actually just click in, and this will bring you to that specific workflow where it was generated. So again, this is really cool for like compliance piece or just lineage purposes for internally at your company. All right, though, let's go ahead and do, I think is a really fun part, is we want to go exit out of this code and go back to the notebook piece. And what we're going to do is scroll down. We want to serve our fine-tuned BERT model now. So we're going to do some live app serving. And this is actually in beta, even in serverless. right now. So if you do see errors here, also let me know. We just launched this, so you're actually going to be, I think, some of the first people outside of Union to use our serving feature, which is really exciting. Right, or in serverless anyway. All right, so now we provide a pretty simple way to host apps, which is really cool, directly in Union and in serverless. And we have a couple files that define this app as the app.py and main.py. Go ahead and run this code because, again, it has to build a container first if you haven't run this already. Mine should actually deploy the app pretty fast because I already have the container built. So again, for you, it'll just take a few minutes. We can see it's thinking. And as that's happening for you, I'm going to go ahead and open up this app.py and app.main. So we want to let's go look at app.py first. Close some of these out. And how's everyone doing so far? It's a lot of information in the workshop and pretty fast, but hopefully you're having fun. And like, you already built a production grade pipeline. Now you're going to go ahead and serve that model. So yeah, let's look at this one first. We have this app.py. We're going to basically make a little Streamlit app. If you haven't used Streamlit before, it's a cool library that allows you to make really nice looking applications with like a simple interface very easily. So we're going to import a couple things here. Now, this is where we're going to kind of declare the artifact. We have that fine-tuned IMDb model. So we're going to say, this is equal to artifact. It's going to query for it when we need it. And then we define an image spec again, but this time it's for running the app, not for training everything. So we can see we have transformers, we have union runtime, we have accelerate, we have Streamlit. And then we are defining our Streamlit app here. We're calling it Streamlit app. It's an app in Union. It's for BERT. You could give this any name, but BERT sentiment analysis, what I'm calling it. It's going to expect an input, which in this case is going to be BERT model. And what's really cool is we'll see this again in another example for batch serving. If you're sticking around, is we can call now that artifact.query is going to bring in the latest version of the artifact. So in this case, it's going to go ahead and look what was the last version that I trained. For you, you probably only have one. And so it's going to pull in that latest version of the model. Download is equal to true. So it's going to download the artifact when the container spins up, not every time that someone queries the app. And then container image. So basically, this is kind of like we've done in task decorators, but it's a different format. This is the same what we want for our live app here. So we want that container image we defined above. We want one CPU, memory just 4 gigabytes in this case, and a GPU is equal to 1. Also, I should note, so by default, GPU equal to 1 in Union, at least by default in serverless. You can change this in like bring your own compute or in flight, is equal to, I think it's a T4 L4 GPU. But we also have some A100s in serverless. So you can look up how to specify specific accelerator types, but it depends on what GPUs are in your cluster. And then the port, this is going to be the port that we're going to serve on in our compute. And then we're saying we are going to look at main.py, which is actually where our Streamlit app is. We'll see this in a second. And then basically when this runs, it's going to call this in like the command, and this is what's going to serve our app. So it's going to look at main.py, or it's going to Streamlit run main.py and tell it what port to be on. So now we go look at main.py. And there's not that much code in here. We're almost done to the cool part of having your app served. Let me get this a little bit bigger. So here we're just getting the get BERT model thing that we defined in get input. This is from the app.py. That's a union runtime feature. And then we're going to try and load that model in. Otherwise, we're going to throw an exception. And then this is all Streamlit here, the ST. So we imported Streamlit as ST. Streamlit title, again, you could add any text here that you want. And then this is just some extra text that we're going to have it add in there. And then we say user input is equal to text area. And then we want it a little bit bigger, so we can paste in bigger reviews. And then you can give it a key if you want. And then we're saying the button is going to be called analyze. And when it's clicked, it's going to try to pass the text, whatever is in there, into the model that we have. And then it's going to return this error. I put the error because there's built-in patterns where it's like, this is basically, it's going to return red if it's a negative sentiment. And if it's a positive sentiment, it's going to return green. So mine is probably up and running. I think yours probably should be by now or close to it. The container is probably close to being built. We can see some logs here. And then once on this page, once it's green, if yours is still building, it'll say starting. you can click here on this endpoint. And the first time you load it, it might take a second as it's still kind of spinning things up too. Then it should load pretty fast for you. And I think right now, this actually literally might have just been changed too. I think right now in serverless, you have to be authenticated and logged in to view it right now, but that's changing very soon. Like I mentioned, this is kind of in beta. So soon you'll be able to pass in another parameter just saying like, do you want authentication or not? And then actually have this as a public URL. So right now, if you share this out, not being authenticated, you won't see this. So it's a really good way for you to kind of experiment with your app. But then again, very soon, you'll be able to kind of just instantly have this served out at a URL that you can share with other people. All right, so let's go grab a movie review. Well, first, let's just throw in a text. Let's throw in something easy. We'll say, I liked the movie. And let's see what it returns. It says that's positive down here. And it's, pretty confident. If you can see this, I can try to zoom in. And we'll say, I hated the movie. I'll hit analyze, negative. And then let's go grab a longer review. This is from the movie Anora. I heard it was good. I haven't seen it yet. If anyone else saw it in the chat, let me know. So this is much more complex and really long. And let's hit analyze. And it correctly classifies that as negative. And then let's go get maybe a longer complex positive one. Let's see. This one's interesting because it's 3.5. So that's, I think, a pretty positive score, but it's not the most positive score. Hit analyze. And, it thinks it's negative. So like I was saying, it's kind of interesting. It's a complex thing. And also, again, keep in mind, our model was only trained on a very small subset of the reviews and for 3 epochs. So to get a better results, we would probably want to train our model much longer. Let's grab, maybe this one's more positive. See how it does on this one. Also wasn't trained on this data set. This is Rotten Tomatoes, not IMDb. So there also might be some different formats there. And positive. So that predicted that it was positive. So now I have a whole kind of app thing here. All right. So I see some questions in the chat. Let me try to catch up here. So one person asked, the app is deployed. How can I access the Streamlit URL? So once your app is deployed, and if you're ever lost, like you could be here to get to your app page. There's a little app icon off to the side. So click on apps. It says it started for me. Click into this. And then you can copy the endpoint, or you can click on this URL here, and that'll bring you to the app. You can see it loaded really fast for me this time. So hopefully, Amir, that worked for you. Let me know if not. And then somebody said they got an error message. No containers found for the given select in your BERT sentiment analysis log. Is that for serving, like in here? And also, it sounds like Amir, you were able to get it work. It said it deployed anyway, right? So again, this is a super beta, or maybe it's even alpha. I'm not quite sure on serverless here. So if there are any errors, this is great for me to kind of catch them and fix them. So you might run into some errors. Like I mentioned, I think you're some of the first people to actually get in here outside of Union or outside of other customers we've been working with on it. So definitely give it, some room for being a little buggy right now on this serving piece in serverless. Someone said they can see the Streamlit page. Awesome. Super glad it worked. At least for one person, you were able. I know the pipeline stuff would work. The serving piece, this Streamlit piece, again, like I was saying, this is super new. So this is very exciting to see some other people in here. For the person who was having the error, if you can share more information on it or where the error is, maybe more about what it says. And then also, if we can't figure out right now, join the Slack channel. And if anyone else is having errors or anything like that, you can join the Slack channel. I know there's a channel for workshops. There's probably another one you can post in, and maybe put the whole trace or even like an image there. someone said it worked for them as well. Amazing. As for the person who it didn't work for, I mean, it sounds like you were running it from the notebook, so this probably isn't the case. But sometimes, like if you forget to run one of these things, we only ran a couple things, so probably isn't the case. And it sounds like you ran them all. But sometimes it'll be like if you didn't run the previous step or something like that. Oh, they said they think it's working now. Amazing, perfect. Cool. Yeah, it could have been, like I mentioned, it could have been something on our end since it's not fully polished yet. And then again, if you have this running, you can, and no matter where you are in here, you can hit apps, see which ones are running, and then click on this. And then if you want to stop it, there's that stop app button. I think you can also do it from here. You can hit stop app. So right now, you'll notice it's using your resources. So yeah, it's using a GPU, it's using a CPU. So again, we're using the cheap version of a GPU, and you're on your free $30 and stuff like that right now. So obviously you're not being charged for it, but just keep that in mind. Like as this app is running, it's going to be using the resources, so you can always stop it. And then also, I don't think this might be accessible in the SDK or not. I forget what the default time is. So after a certain amount of time, the app should spin down if no one's using it, and then it can spin back up when someone revisits the URL. But again, that might be a little buggy right now too. And I need to find out what the default time to life is on that. So basically, you have a time to life saying like this is active for 5 minutes, and then when someone hasn't used it for 5 minutes, then it would spin down those resources. And I made that number up. I'm not sure what the number is by default right now. So if you want to, you can stop this app. Otherwise, you can keep playing with it. I'm going to hit stop on mine. Before we wrap up the workshop, I'm going to go through and actually show just 2 more ways of deploying this model. So now we have that artifact, which is really cool. So again, also, if you went through and followed along, you built a whole production kind of grade pipeline. Again, if you're, if you might have a more complex pipeline, like in the real world potentially, and you also might have this kind of divided between teams potentially too. So in this case, we just have one pipeline or one workflow that has like our downloading data. We even do a little pre-processing in there, like splitting it. But you might have like a whole data engineering team realistically, and then you might have an ML training team, and then you might have an ML engineering team that does like shipping the model out, and maybe like quantization or something like that. So you might break up these workflows into different pieces, but like you kind of saw, if you're creating artifacts between these workflows, then you can just query for the latest version and easily pull them in and collaborate with your team across all the different functions. So one other thing that we'll see here is serving our model not in an app like that, but for batch inference. So batch inference is really cool if you just want to spin up compute and then do a whole bunch of predictions at once, and then you're not paying for like that compute to always be up. And so this is really useful if you have like a big chunk of documents. So let's say you have like thousands of documents and or thousands of reviews in this case, and you want to classify them all just really quickly and then have them all saved somewhere. And that's a really common use case, is using batch serving for stuff like this. So here we have a batch inference workflow. So I can open up this workflow. We actually have 2. I'm going to go to, I'll bring up this actors one here in a minute. Basically, we're going to be looking at batch inference with a regular container, which is kind of like we've already seen when we ran that pipeline. It spun up compute, it did something in there, and then it spun it back down. And then we have faster batch inference with actors. And so actors and union are a cool way where you can spin up a container, and then you can give that container a time to life. So you can say this container is going to stay up for 5 minutes. Until like it stopped being pinged, and if no one sent anything to it for 5 minutes, then it's going to spin down the compute. And this is really helpful. Like one, if you're doing batch inference and you might need to send multiple calls to that container, instead of like spinning up, doing predictions, spinning down, spinning up, and doing predictions, spinning down, spinning up, doing predictions, it's just going to spin up once, and then you can keep sending files to do predictions, or batches to for predictions, and then when you are done, it will spin down, and you can define that time to life on it. So we'll see that here in a minute. You can also use it in pipelines. So if you had the same compute resources between all these different tasks or something, you could just have an actor and say, live for this amount of time, and instead of spinning up a container for every single task, it's going to live, and potentially that can speed up your pipeline a lot. It just depends on your use case. So it's a really cool feature. It's a long running stateful container. So also if you want to do different state management things in there, it's a really cool feature for it. But we're going to look at both of those, serving with the regular container and then serving with actors. So these are really simple workflows. I'm just basically passing in that fine-tune model. Again, we're doing that fine-tune model.query like we saw before, bringing in the artifact that we have saved. And then we're just doing the prediction on, this is actually the same one that was in our training pipeline. We're going to pass in that model, pass in some text, and then get the return predictions. And then for actors, basically same thing, but it uses the actor container, which if I go to this containers.py, these are our requirements for our regular container. An actor environment has a few other parameters. So we say what compute we want for that container, not in the tasks like we had to do for the other one. And then we also give it this time to life in seconds. So this is going to stay alive for 6 minutes and then spin down once once we've stopped like sending batches to it. But you could change this for longer. It could be a lot shorter. And then let's go look at our inference.py real quick. So this is our batch sentiment. Again, we already kind of looked at this, I guess, for our pipeline one. We're just loading in the model, passing text, and then we're going to get the predictions. And then the actor is very similar, except for we have this one thing up top called actor.cache. So this means when we spin up our container, we're going to load in our model and then cache it. And then every time we send a batch to it, it's not going to load it every time. So it's a state that we get to manage in that stateful container, which is really cool. And we'll see how this is much faster for our batch inference case instead of spinning up each time. But you could also imagine using this for your training pipeline if you have use cases where that's useful too. So let's go back into this little notebook part. And we're going to run this register workflows. So before we used run, and I think that actually might not register all of them because we ran a specific workflow. So we're saying register all these workflows. Now these are all registered in Union or in Flight. And then we can call them using the Union Remote SDK. And so like I mentioned, you could actually do everything we did in the UI before through the Remote SDK as well. In this case, we now have these registered workflows and we want to access them. And we're going to use them for the batch prediction. So here now we have a function I'm making called predict with container. And we're going to pass in text, which is going to be a list like we saw when we defined it. And that's going to be data that we get to pass in right now. And then we're looking at this specific workflow, which is fetching from the remote thing that we just established. And then this is the name of our workflow. And so by default, it names them by like the folder they were in, and then the file name they were in, and then the function name of that workflow. And then we're going to create an execution, pass in that workflow, pass in the inputs that we're expecting. And then we have this wait equal to true. This is going to block the execution until it returns the outputs. Otherwise, this could just go kick off the job and we could go to the next code cell. But this is going to kind of make it wait and then return what comes out of that function. So now we hit this next line. It's going to call this function. It's going to look for this workflow registered, and then it's going to kick it off. And we can see that it's spinning here, thinking for a little bit. And if we go to our Union platform and go to executions, which these are all the executions for, like, you probably have one or two in here from fine tuning. But I have a whole bunch from other stuff. You can go search and find all of them and see which ones were successful, see which ones failed, click in them. Here's the one that we just kicked off. And it's that batch, predict batch sentiment. And we can see that this is running now. So again, it has to spin up the container, load in the model, and then return the predictions to us. And we see it's done. We can see the inputs here where I love this movie, I hate this movie. And then we can see that it gave us those predictions just like before. And then there's a little bit of a delay of communicating from the server, from the container, all the way to the notebook. So this is going to take a little bit longer before that actually reaches here. So let's see how long it takes. So it took about a minute to run this whole code cell, and we can see we got those numbers returned. So now let's do this with actors. And like I mentioned, actors are very similar, except for you don't have to spin up a container every single time, because that container is going to be living up there now. And then you can ping it multiple times before it spins down and get predictions from it. So same thing, but we're targeting our actor batch inference workflow. And then we're going to call these 3 times quickly right after each other. So if we go back to our dashboard, you can see the first one is being called right now. The first one, as it spins up the container, is going to take about as long as the non-actor container here, because it has to spin everything up. And then once it's up, now it's going to stay up and stateful for about 6 minutes. And so we can keep calling it. So the two after in the code cell are going to call it while it's still up. And then we should get the responses here much faster. So we got this first one. It's about 31 seconds. Actually, I think for the notebook, no matter how fast they go, it's going to be about 30 seconds here just from the communication between Union and the notebook. But we can go look at execution times here. So we can see when we did the non-actor one, it was like 31 seconds. And then the first time we ran this actor one was 23 seconds, so about the same time. And then when we called the actors again, it was just 1 second here. So it's returning way faster. So it's kind of like a cool way of doing near real-time inference when you need it for batches. So a really powerful feature depending on what you're building. So it said, this was a pretty nice example of sentiment analysis. Bert, can we do more advanced tasks using newer models? Maybe a math grading task on a reasoning model. Yeah, so you can change, you could build this whole pipeline. Like, well, so for serving, you could easily serve like almost any model as long as you have the compute or serverless has the compute for it. Very similar to like what we did. And I'll be building way more examples of those out. But also for the fine tuning piece, let's go back and look at our actually, let's look at the model one. So if you want to bring in a different type of model, again, we're using Hugging Face here. So most of those models live on Hugging Face now, which is really cool. And here you would just have in like define or make sure you're importing the right model type from Transformers library. And then here we're getting like passing in the model name. So again, we're expecting a auto model for sequence classification, but you could do like the what's it, causal ML or conversational LM type. I think it's causal ML that they use for it. And then so you would just switch this out, pass in the model name for that, and then would download that model. And then you would just make sure you change the relevant things like in the fine tuning phase. You might have to do a little bit different, like if the data looks different, some different pre-processing steps. But then for the training, just change this out to be the right model type as well, and anything else you want to hear. So actually very easy, I think, kind of to take the foundations from this and switch it to more complex models. And so this is like a quick thing that we were able to go through a lot in the just over an hour now. But you can bring more complex models in for sure. And that's what a lot of people actually use Union and Flight for, are for really complex like batch workflows and big models. And if you have any specific ones in mind, let me know, because I'm actually working on putting together some more examples with them. So obviously DeepSeek, everyone's talking about. I haven't looked at fine-tuning DeepSeek, but that'll be something that you can quickly run in a Streamlit app too if you just want to download it. One thing you can also do is build like a RAG pipeline. So you could take data, create the embeddings, put those in a pipeline, or sorry, put those in a RAG database. And you could do that complex pipeline here or that text processing piece here, maybe even save to an external RAG database, and then have a model serving on like Streamlit with Union, like we saw there, and then have a chatbot with a RAG database attached to it. Also, they said their Omni Judge model on Hugging Face. That looks cool. Oh, but it might be too heavy. You might need to quantize it. Yeah. So one thing, like I mentioned too, serverless does Union serverless, what we're in right now. This kind of a little bit more basic version of Union, but you can grab, log in for free. You don't have to set up a whole cluster anywhere like that on AWS. This does have some A100s in it too. So you could potentially run it on an A100. Another thing to look at too is to see if you can run it with the Accelerate library, which like I had mentioned, allows you to offload portions of the model, I think, into some other memory, and it might work. I'll look at that to Omni Judge, though. I'll make a note and see if that's something. It sounds cool. Omni Judge. Hugging Face. Is it this one? Oh, the mathematical evaluation one, like you were talking about. Cool. I know right now there's a Kaggle competition going on, I think, for math. But yeah, most of the Hugging Face library is like, okay, so you would just change this. Like we had that auto model for sequence classification. change that up to this auto model for causal ML, and then you would pass in this, and then it should be able to download it. And then I would have to look at memory requirements for this one. But you could change different accelerator types, like I'd mentioned in Union as well. But this looks cool. I will check it out. This would be a really cool example to play around with. So thank you. I'll share this in the chat too for anyone who wants to check it out. And that's kind of all. I know we're over time. I tend to go over and show off and look at other things. That's kind of all I had planned to show here. So again, if you I don't know if you'd built pipelines before, but you were able to go through, and I know it might have felt fast. We went through a lot, so it's okay if it felt kind of fast paced for you. You can come back, look at the code. But again, you were able to go through and build an actual production grade pipeline. Again, maybe relatively simple, depending on what you want to actually do, or if you're working on more complex models at work. But we have caching, versioning. So again, every time we relaunch this, it's versioned. You can go see all the different versions in your executions. You could go look at different workflows here, and this is an older one. But again, you can see version ID, so you can go back and see. If we look at artifacts now and actually look at our model, and we look at the lineage page, we can actually see now that, this is where it generated from. And now we can actually see that that model is used in all these different workflows that we passed in. So we also saw how to do data lineage for potential compliance, or again, just that can be useful internally for you as well. Click on these, it'll bring you to the exact workflow. And then you have different artifacts and stuff, saved in here. So really cool. At least I think it's really cool. Hopefully you all thought it was cool too. Let me know, is this interesting? Did you learn something new? Was it fun? Do you feel cool that you were able to go fine tune a large language model, even if it was just a BERT model, which again might seem like a relatively simple one, but they're still used for tasks like classification and named entity recognition and stuff like that. So it's still really powerful to know how to use those models. Just might not be the coolest thing or whatever this second for the code generation or text generation. But keep an eye out. Wherever you found this event, we'll be doing more. I'll be doing more complex models, more complex workflows, more on serving, especially as we have more features coming out around that. I think it's a really cool thing that you were able to go through, build a pipeline, and then actually have a model served, which is cool. Mir said it was awesome and fun. Great presentation. It's a lot to cover in 1 hour. Yep. Yeah, it's a lot for 1 hour. So again, don't feel bad if any of it felt like it was over your head or anything like that. This is a lot crammed in. It's a get started quickly kind of in building pipelines and MLOps. But hopefully you had fun, and hopefully you did learn a lot or learn something, and you want to go learn more. That's kind of the idea. I think behind a lot of the workshops I do, I love kind of breaking down that initial barrier, get you building with something, and then obviously you can't cover everything in the hour or even a 2-hour presentation. So hopefully you want to go learn more about MLOps. With that though, I think I will wrap up the stream. I'll share one more time if anyone wants to connect with me too. I usually share a lot of stuff around MLOps or robotics. And like I mentioned, the AI book club is really cool. If you're studying machine learning, it's a pretty fun kind of event. It's been really good having the accountability to actually make me read the books. And so this month we're reading RAG. No, it's not RAG driven development, but it's RAG generative development, I think. So it's a whole bunch of different RAG methods, which is really cool. RAG is retrieval augmented generation. If you haven't used it before, that's how most LMs interact with text databases and then can provide better results with that. And there's a whole bunch of different RAG type methods. And so this book goes into quite a few of them. And then we're reading AI Engineering by Chip in March. And if you have any book recommendations, let me know as well. And if you don't want to use up all your resources, again, I think it should auto scale down, but make sure you go to your apps and then stop your app as well. But with that, thank you, everyone. I think I will wrap up the stream unless there's any other questions. If you have any other questions, find me on Slack or LinkedIn is a good place as well. All right, I will talk to you all later. Sounds like some of you had a lot of fun. Hopefully, you'll stay in touch and share cool stuff that you end up building. Bye.